Okay, the first thing that we're going to be looking at is how to convert binary to decimal. Now when we talk about numbers, we tend to think of them as a decimal. So if we took the number 147, what we're actually saying is, and you perhaps did this in primary school when you were learning about numbers, is that we're actually saying that there are 7 ones, there are 4 tens, and there is 1 100. And that obviously increases by a factor of 10, which is why we call it base 10. So what we're actually doing there is we're saying 100 plus 40, because there's 4 tens, plus 7 ones, which of course equals 147. Now because we're dealing with a decimal number, and we won't always be, we identify that by putting a small 10 just after the number. So that's how decimal numbers work, which is important to understand how binary numbers work. So if we had the binary number 1, 0, 1, 1, what we're actually saying is that there is 1, 1, there is 1, 2, there are no 4s, and there is 1, 8, because binary uses base 2, so these all increase by a factor of 2. So we can say that we've got an 8 plus no 4s, but plus a 2 and plus a 1, which when we add them together would give us the decimal number 11. So 1011 in decimal is 11. Now when we write out the binary number, you always put the number 2 as a small superscript there, just to show that that number is in binary and that we're not actually referring to 1011 in decimal. Okay, obviously that's quite a simple example. When you do your exam, they're likely to be written with 8 numbers, because if you remember back to bits and bytes when we looked at that, there are 8 bits stored in a byte, and that's the size of memory that a computer deals in. So you may be given the number 1, 0, 1, 1, and then we tend to write a space between them, and then it would be something like 0, 1, 1, 1. Okay, so if you were asked to convert this number from binary to decimal, you can do this on the exam paper. It's probably a good idea, just to stop you making some silly mistakes, is you can write the base 2 above. So 4, 8 times that by 2 is 16, 32, 64, and then 128. So if we then to convert this into decimal, we would say that we've got 128 plus 32 plus 16 plus 4 plus 2 plus 1, which would equal, and now you've got to trust that my maths is okay, so it's 130, 160, 176, 183. So that number there is 183 in decimal. Okay, so it's fairly easy to convert from binary to a decimal number, but you obviously may also be asked to do that in reverse, so you'll be converting decimal back into binary. The process is fairly simple, but it is quite easy to make mistakes, and it's worth double checking what you've done twice. So if we were asked to convert the number 83 into binary, then again it's probably worth writing out your base 2 along the top so that you're not going to make any silly mistakes. You'll get used to writing these numbers out. They'll become more familiar to you the more you do them. Okay, so we can say, can we fit any 128s into 83? Well, we can't, so we write a 0 there. Can we fit any 64s in? We can, so we can put a 1 there. Now there's different ways of doing this. We could say, okay, take 64 away from 83, see how much we're left with, can we fit a 32 into it? Or we can say, if we were to add 32 to 64, would it be bigger than 183? So if we do that, that's obviously going to be 96, so we can't put a 1 there because it would take us above our 83. So 64 plus 16 would take us up to 80, so we know that we can fit a 16 in. Okay, so we're now up to 80, which makes the last bit a little bit easier, because we know we can't fit an 8 on because we're already at 80. We know we can't fit a 4 on because that would take us up to 84. We can fit a 2 in, which takes us up to 82, which means that we can then have the final 1 to take us up to 83. So 83 in binary is 0101 0011. Okay, if we just do one more example. If we have the number 147 in decimal and we need to convert it into binary, we would write out our thing again along the top, so 64, 32, 16, 8, 4, 2 and 1. And then what we're going to do is exactly the same thing again. Can we fit 128 in there? Yes, we can, so we put a 1. If we add 64 to that, that's going to take us to 192, so we can't have any 64s. Can we add a 32 on? So that would take us up to 160, so that would be still too high. Can we add any 16s on? So that would take us up to 44, so we can fit that in, so that's taken us up to 144. So the last bit should be fairly easy again, so we've only got 3 left to find. So there's definitely no 8s, definitely no 4s, but there is a 2 and a 1, which adds up to our 3 that we still needed. Okay, now we can check that using a binary conversion table. So 147 should be 1001 0011. So if we find 147, which is a little bit higher up, 1001 0011. So you can see that we've converted that correctly, and you can check those. You just need to Google binary decimal table and you can check some that you practice doing when you're revising.